Okay, let's get started. Hello, everyone. Thank you very much for joining us this morning for today's CNCF webinar, Building a Cloud-Native Technology Stack that Supports Full Cycle Development. I'm Jerry Fallon, and I'll be moderating today's webinar. I would like to welcome our presenter today, Daniel Bryant, Product Architect from Ambassador Labs, or formerly known as DataWire. Just a few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can at the end. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of the Code of Conduct. Please be respectful of your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinar page at cncf.io/webinars. And with that, I'll hand it over to Daniel to kick off today's presentation.
Thanks, Jerry. I appreciate that. So welcome everyone to Building a Cloud-Native Technology Stack that Supports Full Cycle Development. Now, as I was rereading the title today, I was thinking, wow, I've picked way too many buzzwords there. So let's start the talk by unpacking a few of the things I'm talking about today with a kind of high-level takeaways, high-level TLDR. I'm hoping many of you on the webinar, are realizing that being cloud native is a good thing. Cloud native is a slightly nebulous term, what we'll look at in a second, but it's not just about the tech. It's about the culture, it's about the workflows. And in particular, I think workflows are essential in terms of how we as developers and operators interact with the platform. And creating a supporting cloud platform, and many of us are choosing Kubernetes as our foundation here, but what you level on top of these things is super, super important for how we use the platform to deliver applications and ultimately deliver value to our customers. I'm going to break down that the four components of a platform are container orchestration, no surprises, this is Kubernetes, progressive delivery, edge management, and observability. Now, this is going to be a kind of a high-level talk, just to set expectations. We're not going to be looking at lots of YAML. I'll give you a few links at the end where you can get started if you do want to spin up an application-ready Kubernetes cluster with all this kind of stuff good to go. I've got like a free sort of link for a project, the Kubernetes Initializer I'm working on at the moment, and that can get you started very quickly with playing with all these techs. But the talk itself is going to be quite a high level. And what I want you to take away, kind of meta point, is consciously design your platform and watch for anti-patterns. I've sort of come from the Java days and monoliths, VMs, and I really had to update my mental model when moving towards cloud. And the platform was a big part of that. I built some platforms on Mesos before sort of Kubernetes was locked in, and I made some mistakes, being candid. My team, we made a bunch of mistakes. We made some successes as well with various projects I worked on, but consciously design your platform to enable developers to, and the whole team, to deliver as much value as quick as possible and as safely as possible. This is me at Daniel Bryant on most of the interwebs. You can find me there on LinkedIn, GitHub, Twitter. I'm quite active on Twitter, so I'd love to get involved with tweets. I work as a product architect at DataWire, or Ambassador Labs now. We've literally just rebranded. There we have the Telepresence CNCF project. We steward that. And we also have the Ambassador API Gateway, which we've just submitted to the CNCF too. They're not confirmed yet, but we have submitted Ambassador API Gateway to be a CNCF project too. My background, very much Java development, moved into architecture, then moved into ops. I wrote a book with my buddy, Abraham Marin Perez, a couple of years ago on continuous delivery in Java, so you can check that out too. Let's look at a quick primer at cloud native, right? I'm thinking most folks on this webinar are sort of all in that cloud is a good thing, right? It does offer many benefits, mainly in terms of speed to market, innovation. We can take advantage of cloud techs like machine learning, that kind of thing. And there's lots of other benefits too, scaling, for example, but it does require changes. The technology is the obvious one. And as a techie myself, I get the most excited about this sometimes. When Docker came out, I was Docker crazy. When Kubernetes came out, likely same thing as well. But appropriate culture is really important. Not just the tech, it's how we sort of interact as a team to get the most out of these cloud native techs. And this is all about new workflows in my mind. The old days, me as a developer, just committing code and walking away to some degree, is clearly changed now. DevOps kind of changed that, but even more so in the world of Kubernetes. Successful cloud native organizations I've worked with, both in my role as a consultant, sort of 10 or so years ago now, or 5-10 years ago, and my work I'm doing at Ambassador Labs, and also the stuff I see in the sort of KubeCon presentations and the literature, the two things that successful cloud native organizations have. One is a self-service application platform. Kubernetes is fantastic, but more often than not, it's a foundation which we build stuff on top. And folks have also adopted new tools and full cycle developer workflows. Now, when I'll go into full cycle a bit more depth now, it's an interesting concept. It actually popped out of, I think it was originally Netflix, and definitely Netflix have kind of made it popular, I should say. I've a fantastic blog post here. I've linked off the Netflix blog. They've talked about how they've set up many of their teams, not all, but many of their product teams to be fully self-sufficient. They're developers, they have the business ideas, work with business folks, they code, test, design, release, do everything via self-service APIs. They're not necessarily spinning up bits of the platform. The platform team have already curated that, and they expose it to developers via UIs, CLIs, APIs, all that good stuff. And to be honest, even the non-Netflix companies, because we're not all Netflix, right? But even the non-Netflix companies I've worked with, the successful ones have got some notion of this going on, conducting rapid experimentation, but we as developers, we're not constrained by the platform team, not have to raise tickets to constantly get things modified. This has really been codified nicely by a couple of London buddies of mine, Matthew Skelton and Manuel Pace, talked a lot about this team topologies. And it's kind of grown, I guess, hand in hand with the full cycle development. I know they've been working on this for many years, but this book, it's only a short read. I've literally got it on the desk behind me here. I recommend it all the time to folks because it really breaks down the relationship between, say, stream-aligned teams, as they call them, often product teams I hear as well, with other teams. And the two that I think are most interesting for us in this sort of audience, in this kind of context, is the stream-aligned team, which is the product teams, and the platform teams. And they talk about the relationship, how those teams all interact. And what I think is super interesting is the platform team often interacts with the product teams and the other teams as a service. This is the classic almost platform as a service. Heroku, Cloud Foundry, that kind of good stuff. There's all, OpenShift is building on top of Kubernetes as a PaaS. But I think we, regardless of what we're building or buying, we do need to think about this platform as a bigger concept than just Kubernetes. The four things I've identified, very broad categories here, but is the container management pretty much a no-brainer, right? We're shipping mostly apps in containers these days, maybe functions, but even a lot of the functions are running in containers behind the scenes too. You clearly do need progressive delivery. This is kind of continuous delivery. James Governor, the Red Monk team have talked a bit more about continuous delivery and progressive delivery. Very similar. I really like the concepts behind progressive delivery. It's about delivering value as fast as you can and as safely as you can to customers. Also, edge management is a key thing here as well. You need to be able to control what's released at the edge to various users. You want to do canary releasing, experimenting, that kind of thing. And finally, observability. The edge management and the observability go hand in hand with progressive delivery. We want to separate deploy and release. We want to deploy as much as we like, have maybe 2 versions or more of the app running in production, but we control the release via the edge. 99% traffic going here, for example, 1% to our experiment, and we observe the results, both from a business and a operational perspective, KPIs, SLIs, which I'll talk a bit more about later. If you're more into visuals, this is kind of like someone on the team very kindly drew this up for me. My drawing is really not very good, but this is kind of the visual representation of those 4 things. We're coding our apps here. We're packaging them in containers and deploying them onto a container management platform. This handles the scheduling for us. If hardware disappears, we want to scale out, for example, the container management handles all of that. We clearly need to get our app and our config. It's really important. I've made too many mistakes in my career where I've done config pushes, config changes, and broken stuff. App and config needs to go through a pipeline to be delivered into production. You also want to expose stuff in a controlled manner to users. Maybe running experiments and so forth, but the users are, the edge is where the users meet your backend services. And tying it all together is observability. We need to understand the apps, we need to understand the container management, the edge, definitely the pipeline. I've seen a lot of I think it's the Honeycomb folks talk a lot about observing the pipeline even, which is super interesting too. That's a kind of primer on this notion of full cycle. If you want to know more details, I've put together some blog posts. The team at the Ambassador Labs have done some more work on this as well. You can go into more detail. We link off to all the Netflix posts and team topologies too. But again, I want to remind you that successful cloud native organizations have really thought about creating a self-service platform. They're not just saying, hey, developers, here's Kubernetes. They're sort of putting more things on top. And they've adopted new tools to kind of promote this notion of full cycle development. And I appreciate it is a bit of a buzzword, but I like the ideas around full cycle development. Early in my career, I was raising too many tickets as a developer. Can you create this manifest? Can you, expose this route on the edge? That's gone now. We need to move faster than that. So I really like this notion of adopting new tools and workflows. I mentioned up front about anti-patterns. I've definitely done a few of these myself. So I wanted to call out a few things I've seen, a few things I've read about as well. When you're building a platform, be really careful about centralized control. Platform ops sysadmins clearly want and need centralized control. This is important in terms of guardrails and governance and security and things. But I've seen all too often platform teams be too kind of constraining and not realize really that developers are their customers. They've got to understand, they've got to empathize with customers rather than just giving them what they think they need. On the flip side, I've seen a bunch of dev teams, and I've done this myself, where we've fragmented the platform implementation. We were working on some Ruby apps, some Spring apps. It was a microservice system, and we had a Java version of service discovery. We had a Ruby version of service discovery. Then we brought some Go in the mix, and we had a Go version of service discovery. This is back, 5 or so years ago, but we soon realized we had all these fragmented implementations, and when we needed to do a change, a cross-cutting change, there was like 3 libraries effectively to change, and not a good look. Also be aware of slow development loops. Those of us back in the Java.NET days are used to doing kind of hot reloads on our monolith, literally coding in the IDE, hot reload, look in the browser what the changes are at, or how the changes have taken effect. Systems we're building now are often more complex than that. You can clearly use mocking and stubbing and so forth, but sometimes you need to actually package your app in a container, ship it to staging and test it. And this stuff can take a long time due to the build and push of a container. There's some cool tooling I'll share that can overcome some of these limitations. Diving in a little more detail quickly to each of those anti-patterns. Now, I've worked too many companies, it's only a handful, but too many in my opinion, where it was all good intentions, that the platform teams were trying to do this economies of scale. We build a platform once, we build the CI pipelines once, and our developers can just use those. But too often, the ops teams were not working closely with developers. There was a big company in the UK, I can't mention their name, but I went in there as a consultant and built a fantastic platform, but no one was using it. And I realized very quickly that the reason was none of the ops team who built the platform had ever talked to the developers. So it didn't meet their needs. So it's really important to increase that collaboration of ops and dev. It's also tempting, again, devs, we're incentivized to push out functionality, deliver business value as fast as possible. Ops are incentivized to, not have security incidents, not fall over. It's a little bit cats and dogs sometimes. There is a kind of, little bit of animosity there, a healthy tension. I think is a good thing actually, but we need to be careful. We need to work together as an organization to recognize where the guardrails are needed and recognize where we can override some things. Big one, modification being ticket driven. I bumped into this quite a bit, even a few years ago when I was working on some projects. To expose new routes or configure new edge config, we had to raise tickets with the central IT facility, and they approved, WebSockets, we're allowing protocol upgrades, we're exposing this port or whatever, and we had to factor in their SLAs. I think they were turning around tickets like within 48 hours. Of course, if we need to release an app, we had to factor in the SLA to make sure we synced up with these things. So it's not a good look when you're trying to go as fast as possible. You're trying to go faster than your competitor. I mentioned about fragmented platform implementation, and this really crystallized for me. I was actually doing it pretty much at the time. I saw a presentation by Stefan Tilkov, and Stefan talked a lot about microservices being a great pattern. I've linked the presentation there for you. I think it was about 2 or 3 years ago now. Love microservices, bounded context, hard network boundary. The temptation though sometimes is to build these micro platforms. And like I mentioned already, I worked on a project where we literally built Java service discovery, Java rate limiting, Ruby service discovery, Ruby rate limiting, and there were subtle bugs in different implementations. Updating them was challenging. Ops didn't have visibility. They were complaining they couldn't understand what we were doing. Quite rightly, we were at fault in some ways in that one. So this is kind of the dev version of, trying to be freelance, trying to go as fast as possible, and actually causing more headaches than we intended. Final anti-pattern is the slow development loops. And Mitch Denny did a fantastic blog post, I've linked there, talking about kind of the inner dev loop and the outer dev loop. The inner one being that really fast, sort of, almost like unit test style, TDD kind of feedback, maybe a bit deeper in that sort of integration testing. but getting really fast feedback. And he talked about the commit tax, in that, coding, building, and sort of inspecting, all part of the job. But in some ways, committing the code to the repo, clearly it's part of the job, but it's a bit of a tax. You're constantly doing sort of git push, creating branches and things. And then he extended it, well, we extended it further on, saying, if you're building code in containers, the tax gate's even bigger. You're used to doing that sort of build, hit reload, and then see their results. Well, that works fine, particularly if you're using mocks and stubs, or you're doing stuff locally. But as soon as you need to engage with or work with other dependencies in your system, suddenly you're building the container and then pushing that container up to a remote registry, which can really add a lot of time. We worked on a couple of projects where builds were taking 4 minutes, and you imagine as a developer, that was really hard to keep your context going when you're trying to do these fast iterations. I've got some tools that can help you on that one though. Right, let's explore the platform capabilities. Keeping in mind, full cycle, good stuff, go fast. There's a bunch of anti-patterns we want to avoid. Now, how can we do this if we're looking at our 4 capabilities? Say you're tasked, or you're working on a team that is tasked with building out a platform on top of Kubernetes. What things do you need to think about? Now, this will be a whistle-stop tour of some of the kind of, the goals I see of each, or the team and I see of each of these 4 things. And I'm going to pick out some key decision points and some key challenges I've bumped into over the years too. First, there was container management. Like I say, back 5 years ago, maybe Kubernetes hadn't sort of won the battle yet, but now I think Kubernetes is fantastic, and it's in there. But from if we take a step back, really container management is all about running container-based apps at scale and on a variety of infrastructures. Maybe we're on-prem a bit, maybe we're in the cloud. From a dev perspective, we want self-service interactions. We don't want to be raising tickets for an operations person to say, create Kubernetes YAML for us. Maybe we as developers don't want to know Kubernetes YAML because we're just about pushing code, but we shouldn't be raising tickets. That's going to slow us down. From an ops perspective, it's all about setting those kind of guardrails appropriately. Access control, auditability, who's doing what, these kind of things. It's a constant trade-off with sort of Kubernetes at the foundation here, devs wanting to go fast, ops being responsible for sort of uptime of the platform. Kubernetes decisions. So one of the biggest ones is the self-host or not, I think. This kind of, again, I definitely recommend platform teams work with the devs teams to really understand what the requirements are. I think too often, not temptation, when I did a more of an opsy role, I thought the company I worked with was special, and we sort of custom built some Mesos stuff. And I look back and I think, we could have got away with Cloud Foundry, to be honest. We thought we were more special than perhaps we were. If you are going to self-host, COPS, KubeADM, great stuff. I advise a lot of clients I work with, the Ambassador Labs, to go hosted if you can. Go with something, on a cloud. Love Rancher. The Rancher folks are awesome. Chat to them a lot. If you want to get that sort of cross cloud thing going on. A lot of folks I know running OpenShift, they tend to be more enterprisey. You're buying into deeper abstractions when you go OpenShift. It's kind of a bit of almost a choice of sort of different distros, if you like, different distributions of Kubernetes. You get a lot of benefits by buying into the OpenShift abstractions, but they are sort of on top of Kubernetes as well. So you're kind of buying into the platform, if you like, there. Also need to work with developers to think about, should we go all in on a cloud? There is definite advantages with, going all in on a cloud vendor. You can leverage, even in Kubernetes world, you can leverage a lot of these machine learning services or these storage options, these queuing systems, these kind of things. Fantastic work by, say, Corey Quinn and the team, talking about multi-cloud, maybe not being realistic. Many of us are working in multi-cloud. We certainly do with Ambassador Labs. But again, this is all a conversation for ops and dev to have. Ops should say, what kind of stuff do you as developers need, and get QA involved in the mix too, in terms of how do we need to provision environments for testing, these kind of things. These are all discussions where I don't think ops should dominate. It's a collaboration between all the functions, ops, dev, and QA. From a sort of challenges point of view, as a developer, I think Kubernetes is sort of a foundation for a PaaS-like experience. Now, I know many development teams that do simply write YAML. We do mostly Ambassador Labs. Devs, we write YAML and package it alongside our applications, no biggie. But not every developer wants to do that. And I bumped into a couple of really successful companies recently that rely more on Helm and Helm file. So all developers do actually is they they've got like a custom tool, for example. They might do, init project, and it spins up a GitHub repo, Git repo. It spins up all the kind of structure of like a standard REST type application, a standard web app using Helm. And then the Helm file is used for developers. Like they literally fill in like a values.yaml file for all the config options they want. They don't have to learn how the Kubernetes deployment descriptor looks like, or the Kubernetes service, object looks like. The Helm file values will literally be something like, amount of CPU, amount of memory. Do you want auth on this? TLS, what dependencies as this service should be able to talk to over the wire, these kind of things. And then the developers often just run a CLI tool, and behind the scenes, the platform team have set up this machinery that takes those values in the YAML file and then weaves them into Helm file, Helm, and pushes it down a pipeline and deploys the app into a target environment. It's a really nice way to get all the benefits of Kubernetes, but isolate some of the complexity from developers. Developer productivity. So on a similar note, I struggled definitely when I was sort of getting into Mesos and Kubernetes back in the day of, sometimes I needed to do that fast kind of dev loop, but I had this remote cluster I was pushing my app to. It's basically local to remote dev and test. Thankfully, these days, there's some fantastic tools out there. Obviously, I'm biased. Telepresence, DataWire, Ambassador Labs tool. It is a CNCF hosted open source tool, but we're building on top of that one. Garden folks are awesome. Tilt folks are awesome. K-Sync's useful. Bump into a bunch of folks in the Kubernetes Slack using Scaffold these days as well. And Scaffold is super interesting. Don't suffer like that. There are tools out there to make this part of the experience better. I work with some teams and they're not realizing this, and they're stuck in these long dev loops of, pushing up a container, waiting for it to deploy, then running some smoke tests, and then iterating on their code. These tools are fantastic, to kind of shortcut that dev loop. Moving on to progressive delivery pipelines. This is really delivery pipelines, really sort of think about delivery pipelines. The goal is supporting the creation of pipelines that enable automated, build, verification, deployment, release, and observability is key here. I think that's some of the differences of progressive delivery than, say, continuous delivery, is the ability to experiment more, do more controlled releases on the actual functionality you're releasing, feature flags, canarying, dark launching, all that kind of thing, and being able to observe the results and feed it back into the continuous delivery, progressive delivery lifecycle. This is really, really powerful when you get it done well. From a dev perspective, same deal, right? It's all about automation. APIs, SDKs, CLIs, all the toolings we need to make it as easy as possible without raising tickets for our ops team. We want to just consume the services there running. From a platform team perspective, it is about the centralized verification of quality and security. I've definitely, my sort of fair share time as a developer, not always fully thought about some of the security stuff. OWASP, if you haven't bumped into OWASP, well worth a read about the OWASP. I've learned a lot about threat modeling over the years, so I got more senior in my role. But definitely at the start, I wasn't always thinking about security as probably as much as I should have been. And you can now plug tools into your pipeline, such as, I know Aqua do a scanning, Sneak do dependency checking, scanning of containers. You really need to think about scanning your code, scanning the dependencies you're bringing in for vulnerabilities, and scanning container images you're using. There's free tools out there. OWASP, again, hat tip to them. Commercial tooling, I've mentioned a couple of names already. You can do your sort of research out there, but these are the things to think about. The key goal with continuous delivery, progressive delivery, is rapid and safe delivery of value. And it's context specific. Rapid and safe means different things to an e-commerce site versus a nuclear reactor. Do you know what I mean? I'm thinking nuclear reactor, we're going to be optimizing for safety. E-commerce, speed, because I want to beat my competitor. But we need to understand, work as a team, biz dev, QA ops, come together and understand what's our definition of rapid and safe. And then once we've got that, it's thinking about pipeline practices. I'm increasingly seeing organizations say, not being so controlled about CI, so different teams maybe even using Circle CI, Jenkins, or whatever, but coordinating the deployment and the orchestration of all these deployments using something like Harness or something like Spinnaker, for example. I see quite a bit. Your mileage may vary here. We work with Argo a lot in Ambassador Labs. I love the Argo stuff. It's very Kubernetes native. Just think about what kind of hierarchy you want there in terms of, do you want something overarching control, or can you do everything with Jenkins X, for example, everything with Argo? it often is, think about your problems and then it's match the technology as appropriate. There's a lot of cool tools. The CNCF, CDF are doing a lot of work in this space, and well worth sort of researching and matching your requirements with what technologies are out there. And again, your kind of build versus buy comfort level too. Hat tip to Brian Lyles. I always learn stuff when I chat to Brian Lyles. I'm very lucky on a couple of podcasts, chatted to him. But he did a fantastic talk. I can't remember the name of the conference there, but one of my friends, one of my colleagues at InfoQ wrote up Brian's talk. And he talked a lot about the future of CI/CD being about composability. And I really buy into this kind of thing. That's why I do like Argo for that reason. Tecton, under the hood kind of thing, being able to compose different bits of the process. I really like what the Weave team are doing. So Weave have got Flux. Now they're creating a GitOps toolkit, kind of as the next gen of Flux. And it's all about composability. Here's how you pull in the source. Here's how you do your build. Here's how you do your integration tests. I really like that. It's something I saw well when I was doing, worked very well when I was doing a lot of work with things like Jenkins. We were always putting the plugins in, making our deployment pipelines composable. I think cloud native in this space holds a lot of potential. So progressive delivery challenges, it's all about that collaboration. You really have to work hard to make sure, within boundaries, of course, you can't be collaborating all day and just talking about stuff. You need to do stuff too, but it's about recognizing the platform team, the customers are QA and dev. Getting that collaboration, understanding requirements, understanding the best way of working, starting small and iterating from there. That's the key thing. You've got to balance that one size fits all. It's very tempting. When I was on ops, we did, we liked the one size fits all because it was much easier to operate. But you don't, I've seen a couple of projects where it was just chaos because the ops team, we were too constricting, and the dev teams pushed back and we're doing like shadow IT, spinning up drones, spinning up Circle CI and doing their own thing. So there's a definite balance on these kind of things, but make it easy to do the right thing. I think that's a motto for life, to be honest, but I definitely think it's a motto in IT, in that if you value security, and yeah, who doesn't? Value security is really important. Make it super easy for that pipeline to do the verification checks, scan the code, scan dependencies, scan the container images. Super easy. I've linked James's awesome article there about progressive delivery. If you want to know more, you can follow that link there as well. On to the third component. This is edge management, mainly focused on ingress and API gateways. Now, the edge is all about this sort of self-service notion of releasing functionality by developers while maintaining safety and stability. So as devs, we want to be able to release new code, experiment, try things out, but we don't want to expose things we shouldn't. We don't want to fall victim to DDoS or these kind of things too. As developers, it is all about decentralized traffic management. We want to be able, individual product teams go at their own speed. Yeah, so if I'm working on a team and you're working on a team, we may have to coordinate in terms of our dependencies, but we shouldn't have to coordinate our releases necessarily. Yeah, we should be free to release, have our own kind of release trains, our own release times outside of that coordination needed. We also want to support different cross-functional, non-functional requirements. So auth requirements on different services, some retries, like some transactional stuff. Maybe you don't want network retries, but other non-transactional stuff, having a few retries at the network level can mask a bunch of intermittent problems sometimes. Definitely be careful with that one. From an ops point of view, platform point of view, centralized configuration of sane defaults. I've learned a lot from Matt Klein, creator of Envoy, on this, and that I know at Lyft they do a lot of interesting stuff with Envoy about constraining behavior of new services that are deployed. In that if it kind of goes and makes lots of requests to things, it almost gets quarantined. I've seen other companies do that kind of sane defaults and then allow us as engineers to override or have a conversation and override as appropriate. Definitely, I think from the platform team, I chat to a lot of folks in my work at Ambassador Labs around TLS, AuthNZ, rate limiting DDoS. Again, at the edge, this is the first contact with not only your users, but bad actors too. So we have a lot of chats with folks, and TLS these days is pretty much table stakes, but authentication, integration with IDPs like Auth0, Keycloak, Otcal, all that good stuff. And platform teams are often thinking about that, and they need to make it as easy as possible for developers to consume. Keycloak is a fantastic bit of tech, takes a bit of setup behind the scenes, but we as developers should just be able to really, almost put a flag in our config. Yes, I want, Keycloak auth on my service. In terms of edge stack decisions, so edge technologies, Envoy, I think, is becoming the de facto standard. I put a question mark there because I'm sure the Nginx folks, AJ Proxy, Trafic, the folks wouldn't agree with that, and I respect them all a lot. We're seeing a lot, obviously Ambassador is based on Envoy. We see a lot of folks, say eBay, building their gateways based on Envoy technology. All the clouds are investing in Envoy, AWS, AppMesh, Google, I think just yesterday came out with an API gateway based on Envoy for serverless. Like Envoy is everywhere. Lyft, bootstrapped, fantastic project. Google are committing a lot of code. The community around Envoy is just fantastic as well. So I'm very bullish. I own my bias, but I'm very bullish on Envoy at the edge. The XDS APIs are super interesting. So Kelsey Hightower talking a lot about this in relation to what they're doing at Google around gRPC and Traffic Director. So that's more of a east-west service mesh type thing. Envoy, the XDS APIs are how you control Envoy effectively, and now gRPC supports some of those things. So I really do see, not only the success of Envoy, but the success of XDS APIs being really, really sort of the benefits in the future really good. And definitely if you're into specs, pay attention to Ingress v2 stuff. I'm not an expert in that. My colleague Alex Gervais at Ambassador Labs is doing a lot of work with the team, the CNCF team around Ingress v2. I know Ingress v1 was a bit sort of generic maybe, but the v2 stuff looks super interesting. So do pay attention to open standards or standards that are popping up in this space. Think about deploy release workflows. Again, if you're picking an edge stack like an API gateway, proxy at the edge, really the config should support all the good stuff you know and love in the Kubernetes world. Things like declarative config, CRD, custom resource definition config. We want to be able to push our routing, our API config down the same pipeline as our app code. We're deploying, Kubernetes services managed by Helm, for example. Like we really want to be controlling our edge and our, same thing with like if you're using, say, a service mesh, you want to be controlling that using the same pipeline that you're in the same verification as your app code. Needs to be self-service. Again, whatever your comfort level as developers, whether you're writing YAML or using some kind of thin facade or adapter on top, it needs to be self-service for us developers to, just go as fast as possible. Oops. Yeah, so in terms of challenges, I've done a whole presentation on this. I think I may have even done a CNCF webinar on this, but definitely some other, I did a KubeCon talk on this one recently. The two biggest challenges I see at the edge is scaling edge management, particularly if you're going from like a monolithic VM-based thing to Kubernetes. It's a lot more dynamic at the back end now. There's more microservices typically being built versus the monolith. Like it's just more challenging for dev and ops to work close together to scale how you interact with the edge as a developer. I want to release this. I want these auth things, these rate limiting configs, for example. And on a similar tip, it's supporting multiple protocols. We're doing a lot of work with gRPC web at the moment, gRPC in general, actually, and also different configuration of cross-functional requirements. So we're sort of pulling up a lot of the cross-functional requirements from our apps. So no longer am I using a language-specific library to do rate limiting or auth. I'm pulling that up into the gateway. But again, as a developer, I need to control how that's configured for my service. And when you start getting 10, 20, 30 services, all the different product teams need to control those services independently. So respect the guardrails from the ops team, but we need a way of scaling the edge management and the supporting of multiple protocols and the configuration of the corresponding cross-functional requirements. Right, final furlong, heading into observability. Now this, is a no-brainer. Over my career, we know metrics and logging. I think it's very much being talked about in the concept of observability now. I've realized more and more the value of this, both from a tech perspective and a business perspective too. Observability is all about supporting the collection and analysis of the end user and app feedback, and it should be configurable by both developers and the platform team. Often they have different goals here. I think from a dev point of view, it's enabling us to observe and iterate against business goals and key performance indicators. Is this change making us more money? Is this change driving conversion, for example? Ops team, I think, is more focused around service level objectives, SLOs. There's the core kind of, golden signals, red metrics, and so forth. Use, the popular one we talk about, usability, utilization, saturation, error rate, these kind of things. Platform teams tend to be a bit more focused on below the app, the platform itself and the infrastructure itself. But we've got the same goals. We make sure the app is delivering value, is not crashing, is secure, all these good things. So we really need to bake observability into the platform from day zero, right from the app to the edge and all the way through our platform. Decision-wise, lots of interesting tech out there. Be careful and start small and go big. It's tempting, I think, when folks bump into all these cool CNCF hosted techs, all the commercial techs out there, you can kind of monitor all the things. And I think in some ways, the more things you monitor, the more confusing the picture is. So my advice is, start small and expand out these things. Do think about standards when you're making technology selection. And a fantastic podcast, you can check it out on the Ambassador Labs podcast with Dave Sudia from Go Spot Check. And Dave talked a lot about how he invested a lot of time thinking about the adoption of standards for observability, so that he at the start he could just use a hosted solution for spitting his metrics out, and then when he if you scaled out, for example, he could maybe run his own Prometheus cluster, these kind of things. And it was really interesting hearing his decision points. And one of the key points he was really pleased that he and his team made was that they'd invested in this standards as a kind of adapter facade that they could then over time not have to modify their code, but they could change the back ends as the scaling requirements changed, as the cost requirements changed, all these good things. So again, hat tip to the CNCF here. Lots of great work going on around open metrics, open tracing, all this kind of good stuff too. But do think about this in the context of metrics clearly, logging super important, and distributed tracing too. The hardest thing, I think, is joining the dots. And this is why fantastic work by Honeycomb and Lightstep, really thinking about detecting errors, detecting issues like sort of bad performing SLIs, for example, locating where they may be and helping us as engineers to zoom in and figure out exactly what's going wrong. This is something to really sort of invest in, really think about. I'm happy to pay money for a lot of these things, to be honest. I'm not going to be building my own observability dashboard, I don't think, in my team. We're happy to pay money for other folks to do this for us. Do make it so that it's easy to do self-service config and dashboards. This is a key thing. Again, I worked with some fantastic teams recently where, as part of the tooling I mentioned earlier, where a developer just says, initialize me a project, a dashboard gets spun up automatically in their metrics, Grafana, for example. As a result of creating a project, they get some basic hooks in to the application. So in the Helm config, it's all the wiring up to their Prometheus, all the wiring up to various other, I think, Jaeger or OpenZipkin, that kind of thing. And this is really cool because, like, from day one, I literally get like sort of a full scale dashboard for me to understand my app at a very basic level. And I can add more metrics and so forth into the actual application as I go along. More KPIs. I literally code it in using a standard interface, and that gets spat out to my metrics collection. Be careful about increasing signal to noise. It's very easy to start recording all the things, and again, I think that's where devs are often. I find I learn a lot from chatting to the ops team here. I say, hey, what kind of things do you think would be interesting signal, queue depth, latencies, these kind of things. You're always looking. You're not just looking to collect metrics for the sake of it, not Pokemon, as the joke goes. And I've made that mistake myself, where I monitored stuff because I could. I thought it might be useful, and yeah, I didn't really think about how I'm going to use that. Fault location is a key thing. Again, massive hat tip here to folks like Charity Majors, Cindy Shrutaran, Ben Siegelman, for example, and they have thought about this stuff in a lot more depth than I have. I know, like, probably Charity, I was just thinking as I was saying, I'd probably argue that you should collect all the metrics. Maybe, don't look at them until you need to, but this stuff is really important. Like distributed tracing, I'm working a lot with the Ambassador Labs team at the moment around this, because distributed tracing, if you're building these deep systems, you're building these microservice systems that go 2 or 3 layers deep, even if you sort of roughly know where the problem is, you often need something like distributed tracing to figure out exactly where the problem is. This service is latent, or this particular request was at fault, and this stuff, like, it's very easy to not think about it up front, and it's really costly to go back and modify your platform and your apps to support distributed tracing, correlation IDs, these things. So wrapping up, hopefully today it's been a whistle-stop tour. Being cloud native requires new tech and workflows. I really like this notion of full cycle development from Netflix. For me, it's codifying, putting a label on stuff I've seen work really well in all manner of companies, from startups to SMEs, SMBs, to the likes of your unicorns like Netflix. We're not all Netflix, but I think there's many things to be learned from this. This separation of platform team and dev team in terms of the interfaces, but also increasing collaboration between dev and ops and QA. I think it's this is really powerful. The Team Topologies book, I'm going to promote it again. It's really helped me codify how everyone in a team should work together to deliver as most deliver the most value to customers as fast and as safe as they can. Do think about the platform in terms of container orchestration. Think about it in terms of progressive delivery. How do you get your apps on the platform? Think about it in edge management. How do you expose the functionality to your users? And how do we figure out what's going on, both from a KPI business point of view, also an operational SLO kind of point of view as well. I'll say it again, consciously design your platform. I work with a lot of orgs that kind of just sort of fall into creating a platform. And again, I'm not judging because I've done it myself on a couple of projects when, as I've been a developer over, say, 10 plus years, 15 years, I've definitely accidentally built platforms along the way. But I think these days the technology is out there. Again, hat tip to CNCF for sort of curating and helping along a lot of these projects. It's really a case of mixing and matching, building, buying appropriately. But do think about your requirements, think about the anti-patterns, work well as a team, and then create the platform that you need. I mentioned at the start, we've got this free tool, no registration required. Pop along, app.getambassador.io, ask you a bunch of questions, as in, if you want to spin up an application-ready Kubernetes cluster, where's your cluster? Is it in Amazon? What load balance have you got? Ask you about ingress, progressive delivery. We've got some Prometheus, and we've got some distributed tracing with Jaeger in there now. You answer a bunch of really simple questions, like 5 steps on a web UI. Out pops some custom YAML at the end in a zip file. The YAML is all integrated and all wired up, so depending on the options you select, it's customized for you. You literally then follow the simple instructions of kubectl, apply, and you can go through, and it's kind of like a playground. If you look on the left, I think 2 weeks ago, I published an article at the New Stack talking about like some of this tech is quite complicated at first glance. So we need a playground to start poking and prodding. And particularly, if you're going to build something, do a POC around the 4 elements of the platform I mentioned there, getting up and running as quick as possible is really beneficial. So free tool, we're out there, we're offering advice around this. We work with a lot of customers that just want to get started as quick as possible, hence why we've created this tool. We'd love your feedback. It's the team and I have only just spun this one up recently, so we're definitely looking for feedback on that. After that, I've dumped a bunch more thoughts. The team and I have done some podcasts, we've done some white papers and things on this building a Kubernetes platform. Not saying we're 100% right, but we've learned a bunch of stuff over the years. We love your feedback. We love to get involved in discussions. Again, you can find me at Daniel Bryant on Twitter, in the Kubernetes Slack, on the DataWire Slack as well. We'd love to get involved in chat. And thanks for your time today.
Okay, thank you very much, Daniel, for a wonderful presentation. We have some time for questions, so please feel free to drop a question into the Q&A box, and we'll get to as many as we can before the end of the presentation. Any questions at all?
I appreciate it. It was quite a brain dump, wasn't it? So we'll share the slides, Jerry, won't we, later on, and folks, feel free to, like I say, find me in all the Slacks. You can ask some more questions as well. Always happy to do that if you haven't got any burning questions now.
Be sure to do that. As I said before, we'll have the slides and recording available later today on the CNCF website.
Brilliant.
Anyone at all with questions?
I can see one question. Jerry, am I okay to answer that one?
Yeah, what are your thoughts on GitOps?
Yeah, I like it a lot. It's very interesting. So I've worked with the Weave folks or chatted with the Weave folks for many years now. They're sort of come up on the London tech scene, similar to me. And I've watched the sort of the ideas develop. I know there's been some really interesting chat on Twitter of late. The Container Solutions folks, I think it was Jamie and Penny and a bunch of other folks chatting online, debating around the benefits of GitOps. So you can definitely pop onto Twitter and get some of the latest thoughts around there. They blogged about it, discussion on Twitter too. My personal thoughts is it aligns with a lot of the things I like around Kubernetes. This notion of a single source of truth, DevOps, we're all committing to a repo, some kind of control loop saying, this is our required version or desired version of the world. GitOps, something like Flux in the middle there, reconciling our desired view of the world with the actual view in production. And again, that just jams nicely with a lot of things I've done over the years. I've done a lot of work using things like Chef and Puppet, and all of them had some notion of a control loop going in there and reconciliation. And I think Kubernetes now is really embracing this notion of that control loop. We just define declaratively what we want, and it happens. So personally, big fan of GitOps. Really like what the Weaveworks team are doing with GitOps Toolkit. If you haven't bumped into the GitOps Toolkit, I did a podcast with Stefan Prodan on InfoQ a couple of weeks ago. Pop along to InfoQ and check out the podcast with Stefan. I learned a lot from Stefan, and he gave us a sneak peek on some of the GitOps Toolkit stuff. So I think GitOps is going to be kind of where it's at in terms of best practices for Kubernetes and cloud deployment over the next 1, 2, 3, 5 years.
Excellent. What are your thoughts on how to deal with observability with edge devices that are not always connected?
Oh, interesting. So when I'm assuming the person there saying edge devices, sort of IoT devices, mobile and so forth. Yeah, that's an interesting one. There's a bunch of interesting protocols, and not particularly my wheelhouse, but where you can buffer things. So I've worked a lot with the, or chatted with a lot, I should say, with the RSocket folks, and we have folks using Ambassador with MQTT, different mobile protocol. Often it's sort of either on-device batching up of stats, and then as soon as you get connectivity, you push those stats up. I know all the cloud vendors are doing toolkits, particularly with this kind of thing in mind, that spotty connectivity. So yeah, I definitely say have a look at the options out there. Have a look at the different protocols out there. Have a look at the different cloud offerings. I even know Envoy Mobile is doing some interesting stuff in this space as well. I remember chatting to Matt and the team. I've forgotten who I was chatting to now, and they were talking a lot about how on the Envoy Mobile setup does kind of almost buffer these things when there's bad connection and sends it up. So there's lots of options out there. Definitely a known problem, I think, at the edge, and there is a few solutions you can pick from.
What are your thoughts about local versus remote development environments of K8's Microscopes app?
Yeah, great question. So I always say stay local as much as you can. So even back from like my sort of fundamental software days, you want to mock, stub, and virtualize as much stuff as you can locally, because locally is where we can do the fastest iteration. And the reality is that when you're using something like Kubernetes and developing bigger microservice systems, there is some notion sometimes that you can't easily mock and stub dependencies, or you don't want to because you want to get a more realistic environment for testing. So I say, yes, stay local as much as possible. As soon as you need to get that dev loop going on with a remote cluster involved, obviously I'm biased, work on telepresence, but telepresence is a fantastic tool. It allows me to effectively put my laptop in the cluster, and I can do, all like my CLI commands, like dig on the namespace, NSLOOKUP. I can curl Kubernetes services locally as if I was in the cluster. So it's great for testing kind of locally. I can spin up a debugger and run my service locally, put traffic in the remote cluster, have it come down to my local machine, debug it, and send it back up to the remote machine. So my colleague, Abe Saxana, did a fantastic talk at the recent KubeCon. So if all the KubeCon videos now are, for the virtual KubeCon are on YouTube. I had a look last night. So if you Google Abe Saxana or telepresence, he talks a lot about how he was doing this like remote dev workflow. Hopefully that answers your questions. If not, feel free to jump on the DataWire Slack, because it's a popular topic, this local versus remote dev environments. And there's pluses and minuses with both things, and we've got some thoughts around sort of best practices depending on where you're at in your dev lifecycle.
How to incentivize key developers to get involved in Kubernetes platform definition? That sounds like platform stuff for developers.
Yeah, no, it's true. So I had a fascinating chat with, I can't mention the person's name actually, but someone at a big UK company asked me the same question the other day. So it is tricky because not all developers do want to care about platform, and that's cool, right? They just want to write cool code and they want to deliver value to customers, and that's what they should be able to do. What I found in my experience running dev teams sort of pre what I'm doing now at Ambassador Labs was I looked for, there was always like one person on a team or maybe a couple that were developers, but they had a kind of opsy mindset. They were fascinated by Chef, fascinated by Terraform, fascinated by Kubernetes. And I would pick their brains. I'd almost have them as champions within the team. And like at one project I worked on called Not on the High Street, myself and Nick Jackson from HashiCorp worked on that project about 5 or 6 years ago now. We kind of had these platform champions in each team, where those are the folks that deliberately wanted to learn about the tech. We assembled, and the ops team picked their brains, said as customers, like, what do you need from the platform? Do you they wanted some new way of spinning up dev environments on demand, so the platform team built that for them. And these kind of champions were the ones that were the bridge between the developers that were just doing business code and the platform team. Somewhat now it's blurring into site reliability engineering, SRE. I do bump into some SRE teams that are kind of doing that role. They're notionally developers, but they're champions for ops concerns in the development area. So I think it's a lot of it is about sort of just leadership and recognizing the folks that are wanting to go a bit deeper in these things. It's not always easy, but that's probably the best advice I would offer at the moment.
And what are your thoughts on Helm versus customized deployment?
Oh, this is, almost tabs versus spaces, right? I do a lot more Helm stuff, I would say, and I'm really enjoying the Helm files approach at the moment. I've seen some very interesting chat on Twitter around Customize, and Customize is built into a lot of the tools, so that's kind of a good thing, I guess. I'm going to say, as in, I think they both have their advantages. Definitely do your own research, match your requirements with what's there. And before I say anything too controversial, I think that's probably the best advice I can give.
Okay, do we have any more questions at all? We have about 5 minutes left. Anyone at all? What is your advice on the Git strategy to adopt when releasing microservices app?
On the Git strategy, so I'm guessing this might be a question sort of related to like mono repo versus multi repo. Again, I think it does depend on requirements. I know many teams have got very successful deliveries with mono repos and then just doing a kind of typical Git workflow. You will notice like tools like Google famously do this, but they have a lot of internal tooling like Bazel, built to support the mono repo. So my default recommendation is to go, this is a very anecdotal thing, so it does depend on your requirements, but my default is to go with individual repos per service. I just find that easier to get started. And then I do a standard, Git model of doing branches, pull requests. I like the idea of, the mainline trunk-based delivery. I think it kind of makes sense from a continuous delivery point of view. When I'm working with the monolith, I will use something like Git flow occasionally. I think Git flow is a really nice pattern, but it's only really appropriate for the release trains, monolithic things. So on the other project I mentioned earlier on, that Not on the High Street, we were using Git flow for our monolith, doing the kind of following the pattern, is well-documented pattern Git flow, but we were just using standard Git practices for our microservices. We had the monolith repo, we're spinning up microservices in separate repos, and each repo was just using standard PRs. Sometimes we had small services where there was like 1 or 2 developers working on them. Everything was done on mainline, on trunk. Some other bigger services, we had a few folks doing pull requests on branches and so forth. So I do think there's plenty of material around there. It's worth having a read online, sort of weighing up your options, mono repo, micro repos, multi repos. And again, everything that comes from sort of the pre-cloud world, like Git flow, do be a little bit suspicious about its application in the cloud world. I've seen a few folks do microservices with Git flow for each repo, and for me that feels a bit heavyweight. So it's bringing that old mindset to the new technology, but it's definitely worth mapping your requirements to the technologies and patterns out there.
Excellent. Well, thank you very much, Daniel, for your time today. And thank you to all of our attendees for joining us this morning. As I said earlier, today's slides and recording will be available on the CNCF website at cncf.io/webinars. Thank you all very much for your time today. Have a wonderful rest of your day. Thank you again, Daniel.
Thanks, everyone. Thanks, Jerry. Bye now.
Bye-bye.